Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by confirming the battery type, capacity, and age so you know realistic backup expectations and safety limits. Once done, shut down the inverter, isolate mains, and put on gloves. Safety first. Next, measure battery voltage and state of charge with a meter, and for flooded cells, check specific gravity. This tells you whether the cells need charging, equalization, or replacement. Make sure to record terminal resistance to identify poor connections before proceeding. You now optimize how the battery is charged and connected so capacity is used efficiently. First, set the inverter charger for the battery chemistry, adjust bulk, absorption, and float voltages, and enable temperature compensation if available. This prevents undercharging or overcharging. Then improve wiring, replace corroded terminals, use thicker low-resistance cables, and torque connections to spec to reduce voltage drop. Finally, schedule periodic equalization cycles. For lead-acid banks, you finish by establishing regular maintenance and continuous monitoring so gains last. Maintain electrolyte levels for flooded batteries, clean and protect terminals, and keep the battery area ventilated. These small tasks prevent capacity loss. Install a battery monitor or battery management system to track state of charge, cycle count, and cell health so you can act early. If backup remains short, test individual cells. Replace weak ones in matched pairs or the whole bank as needed, and retest performance.
Thanks for watching. Consider subscribing if I helped unscramble your problems.